I'm going to build some triangle. Okay, I'm going to just build a triangle first. So let me just have my 1 point, the second point. This is my third point. So I have 3 points as of now, and I will connect those points, okay, and create a triangle. So by a segment. So I'm going to just connect those points. So this is going to be my second side. This is the third one. So this is just random triangle. It doesn't really matter what kind of triangle we have, but this is just random triangle. So as soon as I have this one, I will build a perpendicular bisector. But before I start perpendicular bisector, I just want you remember the definition of the perpendicular bisector. So that's why I'm going to just draw another picture right here so you can see what I'm talking. So whenever you have a line, let's say this is my random line, perpendicular bisector is basically another line cut through that line with 90 degrees. Okay, so this is the line we call, okay, this is 90 degrees, and this is called the perpendicular bisector. If I have, this is point A and B, and this perpendicular bisector, bisect means divides into 2 equal parts. So that means these 2 pieces has to be equal. And we are gonna call this is going to be perpendicular because this is just divide this angle by with 90 degrees, perpendicular bisector. Bisector. So you will see this in the next part in details, but this is just the definition of the perpendicular bisector. So let me clear actually that one, but that is something we need to remember as definition. So if I want to build some perpendicular bisector of each segment, okay, so I'm going to build perpendicular bisector of this line. So since I'm using this widget, so this is going to tell me this is going to be my perpendicular bisector. And if I want to use perpendicular bisector of this line, and this is going to be my perpendicular bisector. So far, it is not that big deal because whenever you have my first perpendicular bisector and the second perpendicular bisector, you see there is 1 point of intersection. But if I want to do this third intersection of the perpendicular, so let's see what happens. As you see, when I build the third perpendicular bisector, I have now all those lines intersecting at 1 point. That tells me this angle is 90, even though you don't see this right away. This is 90, and this is 90 degrees as well. So this is really important to see why this is the case, and then I will just play around a little bit as we go. But when you draw those perpendicular bisector, so you will see these are going to be 90 degrees, and this side is going to be equal to this one because this line is going to be perpendicular bisector of this BC, and the same as this line is going to perpendicular bisector of AC, then I will say this is going to be equal to that one. And if I want to say this is going to be equal to that one, something like that. You don't have to really get the idea like fully at this point. But again, when you build some perpendicular bisector, this is a picture that we got so far, okay? So I'm going to just play a little bit and then you'll see how that's been changed. But this is what we have so far. Let me click again. So if I want to pick 1 point, let's say this is my point, and if I want to change that point, as you see, even though I just changed this point, some different areas, my intersection point doesn't change. Okay, so those 3 lines always are perpendicular to the each segment, but the intersection of those 3 lines is not changing. So this is my still the same point. This is still the same point. So if I want to just call this point a name, actually let me try to do this. So if I want to call this point D, okay, so let's say this is my point D, and if I want to change this point other way around, as you see, still that intersection point D is the same point, but sometimes it's in the triangle, but sometimes outside of the triangle, okay? So as you see, it might be in it, it might be on the triangle sometimes, like here. So we might play around a lot. And this is going to be big deal as we do like to do more stuff. And let me just try to stop right here. And let's say this is my picture so far. But again, this is the intersection point of all perpendicular bisector of the each segment, okay? And we have a name for that point. So this point D is called circumcenter of this triangle. And then I will explain why this is the reason we call circumcenter. And I will just play one more step into this picture. I'm going to draw a circle with those 3 points if I can. So I'm going to just have this my first point, and I have my second point. As you see, if I want to just build a circle passing those 3 points, and as you see, I can do that. Okay, so if I want to just build a circle, and this is going to be my circle. And this is the reason actually we call that point D is circumcenter of this triangle, because this point D is going to be center of the circle that passing through those 3 points, corners of the triangle. So let me just try to play a little bit. Let's see if that's going to change when we play. As you see, if I move this point around, this circle doesn't change. So still we have a circle, but the center point does change some other places. But as you see, it's going to be something like that if I do that. But still, the triangle, if you connect all 3 points and try to draw a circle, you will get a circle. Again, this point is going to be center of this circle, and this point is going to be intersection of those perpendicular bisector. This is really important for us to see because you will use this feature a lot, and as we learn more features of the triangle, but this is the first one. I hope that makes a little bit like more sense compared to the previous one. So let me just try to add a couple more information into my grade so you can see stuff, I think, much better. So if I have, let's say, the angle. So if I want to measure this angle, this side is 270. That tells me this is 90 degrees. This is something I told at the beginning, but if I use my widget to measure it, you see this is 270 degrees, okay? And if I want to do this similar stuff with maybe these two, you see this is going to be 90 degrees, the other way around, 270. And if I want to do like these two, you will get 90 degrees, and other way around will be 270 degrees. So let's play a little bit more. Let's see if that angle change as we move around. As you see, those 90s doesn't change at all because the lines that I draw at first, which is like this line and this line, are all perpendicular bisector of the segments of the each side. So that tells us whenever you draw perpendicular bisectors of a triangle, you are going to get one point of intersection, and that point, which is right here in the middle. So we are going to call this is circumcenter of this circle, okay? So that is going to be center of the circle that you can draw through those 3 points. That's going to be a big deal because if you look at this point, and if I want to connect this point to the all corners like that, okay, so you will see these all 3 are equal to each other. So may I ask someone, why do you think these are going to be equal to each other? Any comments on that? So if I take a look at this line, like this perpendicular segment, we know this, actually, let me just use something else. So we already know this line is perpendicular bisector. So that tells me this piece, same as this piece. Okay, so if I call this is my H, HC and HB are equal because I just draw my perpendicular bisector of this BC. So we know this was 90 degrees, this was 90 degrees. And if I take this point and connect to this corner and connect to this corner, I'm just trying to see if this is equal to that one. So if you look at this triangle, since this piece is equal to this piece, and this piece is the common for this triangle and this triangle, that tells me this triangle and this triangle are congruent because of the side angle side. So if you remember, one of the similarity was side angle side. We have HC and we have 90 degrees. We have this DH and we have BH 90 degrees and this one. So this triangle and this triangle are exactly same triangles. So for that reason, they are similar, but at the same time, they are congruent. So that tells me this piece, hypotenuse, this piece, hypotenuse, has to be equal to each other. So that's why I will say this is equal to that one. And if you use a similar reasoning, so you can compare these two triangles, and then you will say this piece is going to be same as this one. And if you want to use the same reasoning right here, so you will say this piece is going to be same as this one. So that's why at the end, by using those similar triangles, we are going to see that that point D is going to be center of the circle. That's why we can say that's going to be our intersection of those perpendicular lines. But this is just one way to see why this is the case.